right, we are back in what I think is the final video for the year. So this is our review for the Showcase of Learning. I am going to encourage you to have the map that we made out when you take this. So just a reminder, let's go over the map. It's all about solving quadratics. When you approach each problem, you're going to look to see how many types of x's are there. So is there one type? And that one type can appear more than once, but it's just one type. Or is there more than one type of x, which means specifically you have an x and an x squared term in there. Now, if there's one type, see what form it's in. If it's in factored form, then just do that zero product property, which means you just take your parentheses, set them equal to 0, and solve. But otherwise, you're going to assume it's in vertex form, and you do what's called the square root method, where you work backwards in the order of operations. When you're ready to get rid of the square, the exponent, you will square root, and that's where you get your two answers. And it's because of this step, because every problem's going to have a square that we will square root, that it gets this name, because you might not have to do all these other steps. Now, if there's more than one type of factor, or one type of x, make sure it's in standard form, that it equals 0. See if it's factorable. So look for a GCF, 2 terms will be a difference of squares, 3 terms, you make your x. And then when you're done factoring it, go back to your zero product property. If it's not factorable, then we'll use our quadratic formula, and we do have it here. At some point, you will have to have this memorized, though. Not this year, but eventually. All right, so let's get started. So the first thing I'm going to suggest you do when you take the Showcase of Learning is let's organize our problems. Let's circle, okay, the problems that are going to be one type of x, and let's box the problems that are more than one type of x. So more than one type of x, I'm going to put a box. One type of x, circle. One type of x, even though they're the same, circle. More than one type, box. One type, circle. More than one type, box. There are more on the back. One type, even though there are a couple of them, circle. More than one type, box. More than one type, box. These are the same type. There's just a couple of them. So we circle. One type, circle. One type, circle. Now, just so you know, there are 12 problems, and not like this is going to be this way on the Showcase of Learning, but you will have 3 in this form, 3 this way, 3 this way, 3 this way. Just a heads up. So let's start with, maybe we just want to tackle all our circled problems first. So, and then once I get there, maybe I want to narrow it in. So is it in factored form or vertex form? So this is not factored form, but this is factored form. So maybe I'll just take care of these problems first. So I'll set zero product property, which just means you set each factor equal to 0 and solve. And let's go ahead and do that. Let's go back to our cheat sheet and put that in here. Zero product property just means you set your parentheses or your factor equal to 0 and then you solve. Okay? And if you need that little reminder that we have, that one over here, I'll just kind of like do, oh, this goes over here too. So kind of showing you a little bit more of the map now. All right. So now, for this one, I would just subtract 8. Simple answer, -8. And this one, I would add 7 over, and then I would divide by 4, so I get 7/4. All right, let's look at any of the other circles that are in factored form. So that is not in factored form. Factored form has parentheses, lots of parentheses. That's a circle, that's in factored form. So let's just keep this trend up. 3x plus 5 equals 0, x minus 7 equals 0. This is our simple one, just add 7 and we get 7. On this problem, I will subtract the 5 first, and then I will divide by 3, so I get -5/3. And note the negative and note the way the fraction is written. So circled, this is a circle. Now this is technically in factored form. We've seen this. I've made this one purposely pop up in other examples. If you really want parentheses, you can put parentheses around that factor. It's just the greatest common factor that had come out of whatever our original standard form was. So I'll set this factor equal to 0 and this factor equal to 0. And now this one's done. X is alone. But for this one, I'll subtract 8, so I get a negative 8. And I'll divide 3 over here, so my second answer is negative 8/3. So my other two circled problems, these are not in factored form. So I am done with factored form. So now let's hit all our circled problems that are in vertex form and just get through those. Move our addition, subtraction, multiply, divide, exponents, square roots. So back to the circled problems. Here's a circled problem. I'm going to draw my wall, and I'm going to put that little checklist here as a reminder. This is the special part where we get the two answers, so I'm just going to put a star, but it's also here. So this is 2 times x squared plus 4. So I said multiplication and I said addition. We're going to move those first. So I'm going to subtract the 4 over. That leaves me with 2x squared. I'm going to subtract 4 here, and that gives me 72. And now I'll move my multiplication division. I'm going to divide by this 2. So I'm left with x squared. I'm going to divide this by 2, so I get 36. And now when I square root, remember this is our special step where we get two answers, square root, the square root and the squared cancel out, and then the square root of 36, well that's actually a nice number, it's 6, but it's a positive and a negative. And now x is alone and we've solved. So my next circle problem is this one. So this is 3 times x minus 4 squared plus 2 equals 50. So here, since it's so far over, I can keep my cheat sheet visible. So 3 times x minus 4 squared plus 2. So I will move addition, subtraction first. This, not this, because the minus 4 is in the parentheses. So I'm going to subtract 2, and we get 48. And then I have the 3 with the rest. And this was 3 times x minus 4 squared, so I'll move that multiplying by dividing. So I'm still left with x minus 4 squared here, and then 48 divided by 3 is 16. And now I'll get to my exponent, which remember that's where I'm going to get my two answers. So to get rid of the squared, I square root, the square root and the squared cancel out, so I'm left with x minus 4. And then the square root of 16 is 4, but it's also negative 4. So from there I'll deal with the parentheses, but now I have two problems. So I have my x minus 4 with this positive 4, and then I have my x minus 4 with this negative 4. In this case, I'll add 4 and I get 8. In this case, when I add 4, I'm adding it to negative 4, so I actually get 0. So those are my two answers for 5. So the front is done with all the circled. Let's go to the back, and our last two circled are 11 and 12. So let's start with 11. So moving that addition, subtraction, this is 8 times x squared minus 50. So I'll add my 50 over, not going to show as much work here. And then I'm going to divide by 8. And you know what? 50 divided by 8, you could simplify that fraction. You can divide it into a decimal. If I were to simplify the fraction, I can take a 2. I can divide a 2 out of both of those and get 25 over 4. If you're more comfortable with a decimal, you can make a decimal out of it. Either way, 25/4, which is, as a decimal, 6.25. And now my last step is to get rid of the squared. So I'm going to square root, and remember that's where we get our two answers. So square root either of these. The square and the square root cancel out. If you take the square root of 6.25, then on my calculator, that gives me a positive and a negative, because we get our two answers, 2.5. If you square root here, as it turns out, you can actually just square root both parts. The square root of 25 is, there's the positive and negative, 5, and the square root of 4 is 2. And 5/2 and 2.5 are equivalent. One's just the decimal, one's the fraction. So, you know, just do whatever you're more comfortable with, decimal or fraction. 12, so here, to get x by itself, it's negative 2 times x plus 4 squared minus 1. So my checklist is a little further away. Oops, check mark there. Special step, that's our two answers, and then our parentheses. So this is the addition subtraction I'll move first because this is in the parentheses, so I'm going to add 1 first. So I'm still left with this. And negative 13 plus 1 is negative 12. From there, it's negative 2 times the parentheses squared. So I'll move this multiplying, divide by negative 2, divide by negative 2. So on the left side, I'm still left with the x plus 4 squared. And when I divide these, I get a 6. And now I'm ready to undo that exponent by doing a check mark, square root, square root. Square root and squared cancel each other out. And then the square root of 6, again, this is where I get 2 answers. And you know what? The square root of 6 is not a nice number. So we'll just leave it like that. And now to get x alone, we're going to have 2 problems. We're going to have x plus 4 with the positive version of the square root of 6. And we're going to have x plus 4 with the negative version of the square root of 6. So here I'll subtract 4. So I get a square root of 6 subtracting 4. These are not like terms. You can't combine them. And then I'll also subtract